All right. So my name is Matthew Wisner, and I'm going to talk to you about, what we're calling grapheme-centric knowledge transfer. So Mirko spoke about a G2P system. Takahiro proposed this other system. And I'm going to propose this one last alternative. So when we think about what we actually need for automatic speech recognition, we normally need acoustic models for phonemes. We need the phoneme set that this results in, some lexicon that maps our words to phonemes, or you can think about it the other way around, phonemes to words. And our words can then be mapped using some grammar, some language model to G. So the typical system is sort of listed down there. But in under-resourced languages, or in the task and framework that we've been exploring during this workshop, we don't have most of these things. We don't have the acoustic models on phonemes, the lexicon, the phonemes. And this is where graphemic systems really come in. Because all of a sudden, if we directly replace the phonemes with letters, so graphemes, we all of a sudden don't need number 2 or number 3. So you'd think, wow, our problem is maybe close to being solved. Maybe all we need is one little extra component. So we've removed the reliance on phonemes and lexicons using graphemic systems. And previous work has shown that you get little degradation on most languages that are written, are phonetically written. So we're again assuming this correspondence between phonemes and graphemes. So this blue component, the acoustic models, is the only thing missing. So the idea here is that we can do a cross-lingual graphemic model, graphemic acoustic model. So we can use some resourceful language for which we do have transcripts to train our acoustic models. So that would be this blue section here. And I wrote English because I happen to be using English. Now we all of a sudden have our acoustic models. And this, instead of using phonemes, since we replaced everything with graphemes, we map directly to letters. And fortunately, we're working in the assumption that letters in the source language, so English in our case, and the target language, and it's going to be Turkish for what I do, happen to be the same. And so now this component is trivial. We have words and then a language model. So that's sort of the first system we explored. The second system, and this is sort of underway still, is motivated by the fact that, remember from the first half of the talk, we had shown results that using acoustic models trained on one language and using those for topic clustering, for instance, did much better than using phone recognition on a different system. So we might want to really consider actually using acoustic models trained on the same language. So we can't train in this case, but we can use this automatic unit discovery. So here, the system would be, we have a signal, and we can create phonemes. This would be the AUD system. And now we have some mapping between phonemes and letters, or automatic units, that we have to discover. And this is where we use this cross-lingual notion, where we can use our transcripts from the other language to learn this transduction. And then from there, we can go back to getting words and sentences. So this idea sort of was a little bit last minute. So we have some initial results here. The word error rate is not wonderful. And I noticed that a lot of the words that I do recognize are frequent words. I think the language model is sort of dominating. But we have Olur, Olu, Yani, Yani. So I thought maybe one thing that would be more interesting to look at would be to do character recognition straight away. So I trained a character recognizer. So this was just a very simple GMM triphone system, speaker adapted. And so here it's a character recognition corresponding to the same thing. Again, the GMM system is for training the acoustic models on English, which we then apply to Turkish. So for our character recognition, it's better. So that's encouraging. And what's also nice is that a lot of the confusions that we make are confusions that make sense. It's doing something sensible. So it even learns some out of, so this symbol doesn't exist in English, and yet we still recognized it, as well as the dotless I in some cases. I have an example of that over there, I think. So I think there's some promise to this. And so I've presented two frameworks for this grapheme-centric cross-lingual knowledge transfer with preliminary results on the first, which have some room for improvement, but I think that can be accomplished. And the second setup that I mentioned, this one here, is currently under investigation. And I guess that wraps up my portion, and Lukasz will present conclusions. Or Sanjeev will.
Should I present? Okay.